All right, so here's our first example for those free fall problems. So we have example number 1, Mrs. Stewart drops a tennis ball off the edge of a bridge 10 meters high. A, how long does it take to reach the ground below? And B, what is the velocity of the tennis ball as it hits the ground? So first and foremost, I'm gonna draw a little picture. Here's my bridge. Okay, this is me, I'm Mrs. Stewart, and I'm gonna drop this tennis ball off the bridge that's 10 meters high. Okay. Now, if I call this is my initial position, right? And usually when we're talking about the vertical like this, we, instead of having a delta x, we have a delta y because that's the y direction on our coordinate system. You could do either way. You could call this x equals 0 and then call the bottom x equals -10. You could call this x equals 10 and then the bottom x equals 0. I'm going to use y's just because, I'm sorry if you can hear the baby cry. He's fussing, he's napping right now. I'm going to use y's because we are vertical, but remember you can use x. We're just talking about coordinates here. So I'm going to call this y equals a positive 10 meters because that's where we start. I know the bridge is 10 meters high and I'm starting 10 meters off the water or whatever it is because we're on a bridge. My bottom here is y equals 0. And then I want to know, I know that I dropped this tennis ball off the edge of the bridge that's 10 meters high. And I also know, I want to know how long it takes to reach the ground below. So here I want to know what my time is. And then what's the velocity of the tennis ball as it hits the ground? I want to know final velocity equals question mark. Okay. Sorry if you can hear him. He's fine. He'll probably put himself back to sleep, but we'll see. After I finish this, I'll go in there. Now, I have one other thing that I need to, well, two other things actually. Number one, since I'm dropping this tennis ball, I'm dropping it like this. My initial velocity, I'm not throwing it down, I'm just dropping it. So because it's dropped and not thrown, that means that my initial velocity is equal to 0 here. Okay, and that's one of those hidden givens, like I like to say, because they don't specifically tell you that the initial velocity is 0, but you have to infer that because it says that I drop the tennis ball. And then also we know that this tennis ball is going to be flying through the air, right? It's just dropped to the ground. So that means that it's under the influence of the Earth's gravitational field, which means that the acceleration of gravity is a negative 9.8 meters per second squared. And it's negative because I said from this coordinate system, y equals 0 and y equals 10 meters, that means that my upwards direction is positive. So since acceleration is pointed downward, I know that that acceleration has to be negative, okay? Now, I have initial velocity, I have acceleration, I have a change in position, or my delta y, and then I want to know time. So I can use that delta x, but in this case it's delta y, is equal to initial velocity times time plus 1/2 acceleration times time squared. I'm going to use this to find my time because that's the only equation that has all my variables in it that I need and I want. So first and foremost, remember this delta y, that's final minus initial. So that's y final minus y initial, and that equals initial velocity times time plus 1/2 acceleration times time squared. Now you can see here that I would, since I'm solving for time, I could have a quadratic, but in this case, because the initial velocity is 0, that initial velocity times time term ends up canceling out. So that makes our math a little bit easier. So let's plug in our numbers. We get final position is the ground. So that's 0 minus initial position of 10 meters equals initial velocity, which is 0 meters per second, times time, t, plus 1/2 times acceleration, negative 9.8 meters per second squared, times time squared. So we get negative 10 equals 0, because 0 times anything is just 0, plus 1/2 times a negative 9.8. So 0.5 times negative 9.8 is a negative 4.9 times t squared. I'm going to divide both sides by that negative 4.9. And then so I get t squared is equal to negative 10 divided by negative 4.9, which is 2.05 seconds. And then I'm going to square root both sides, and I end up getting 1.43 for time. All right, hold please. We don't feel like napping today. That's okay though. All right, so that's part A, and then let's look at part B. We want to know what is the velocity of the tennis ball as it hits the ground. So here we're looking for final velocity. So for part B, final velocity equals question mark. We could use any equation now because we know every other variable. So I'm going to use the first basic, that V final equals V initial plus acceleration times time, just because it makes my life really easy. It's already solved for final velocity. There's no squareds in it or anything like that. So that's just an easy equation. So final velocity equals initial velocity, which I know is 0, plus acceleration, negative 9.8 meters per second squared, times time, which I just found to be 1.43 seconds. I'm running out of room. So I get a negative 9.8 times 1.43, and I end up getting about 14. So it's 14.014. So final velocity equals a negative 14 meters per second. And remember, that's negative because we have negative 9.8 times time. And it's negative because it's pointed downward. And I said up is positive. So it makes sense that I got a negative number.